So, again, here's my red line that you keep seeing. The movement of that inclinometer and the others tell us that we're moving in the direction of the arrows. Okay? What I've drawn on here is basically an outline of where we see evidence of moving. If you go up to the parking lot, you can see cracks that have been sealed. You come through building L and you know it's separated. You know down here that we're seeing problems with the wall. We know, like I mentioned before, that that building is moving. You see the asphalt shoved here. You see this building being shoved. And you see a lot of asphalt problems for the Dairy Queen. It's being lifted. That's also being lifted. And basically that's where most of the movement is occurring. Okay? So, what's happening? It's my opinion that moving's been going on for a long time. As I mentioned to you, the first evidence of movement, it was thought that most of it was due to expansion, which is something that we experience a lot in this neighborhood. That could very well have been happening. That process could also result in weakening of the soil. The lateral movement is something that we're experiencing now. We know that's a part of what's going on today, and I wouldn't be surprised if it's been going on for a long time. We know that the ground is shearing at 6.5 feet below the parking lot behind the Dairy Queen. It's also shearing at 35 feet below the pavement behind the Dairy Queen. Okay, that's pretty deep to have things moving. And other depths too. I wouldn't be surprised if we've got things moving between those depths. We don't have any indication of deeper than 35 feet. But you know, there's some uncertainty in that regard. But anyway, it's shearing just like that inclinometer that I showed you. I also believe that the strength of this hillside is continuing to decrease as it continues to move. Now let me give you something that you're familiar with that will probably help you understand what I mean by that. We've all tried to blow up a balloon, okay? It's hard to start a balloon. But once you've got it started, it's sure a lot easier. The same thing applies with the soil that you have that we have underneath here. To get it going takes some effort. But once it starts going, it gets easier and easier. And if you've been monitoring what's been going on, the movement seems to be increasing or becoming more rapid. It's an issue because it's becoming weaker and weaker as it continues to move. So, let me tell a little bit about the material. I've already said this. The slide material, the material that we're sliding on, that stuff that we saw in that figure with the inclinometer that's broken, it's already weak material. It's not very strong. It weakens with the addition of moisture. Believe it or not, there's a lot of moisture in that hillside. The data indicates that the water, or the degree of saturation, if you will, is very high inside that bluff. It's received water for its entire lifetime, coming down through the basalt on the top of the airport, and it's worked its way down, and the soil is wet. It's bedrock, it's very moist. In fact, it reaches a point where it's almost saturated, which is very close to where the water is in the valley. Okay? I mentioned to you that it also weakens with additional movement. That movement could be shearing. That movement could also be expansion. Something that you might be interested in. Most of us believe that a building is very heavy. It's not. Typically, a building weighs about the same as a foot to a foot and a half of soil. That's it. So, with the model that we've put together of this hillside, what I've done here is I've put a relationship between the weight of the soil and the weight of the building. The soil that's involved is almost 99% of the weight. The buildings themselves are 0.35%. Now I've added water in here, and I just did that so that you get a feel of what impact water does have. I've already told you that it weakens the material, so that's significant. It also adds weight, and that's significant. But I wanted you to see that if we put a foot of water into that soil over the whole area where things are moving, that only increases about 1% in the weight. Weight is really the driving force that's causing the material to move, all right? And as I will explain to you, one option we have is adding weight at the toe of the failure, or the slide, to help hold it in place. So here's the model that we put together for what's happening today. I show you this one first because this is really all the way from the airport down to the street below. This detailed portion of the drawing is where we have the actual survey. This detail is just off of a contour map. You see two colors here. Based on what we've learned so far, all of the light colored material is potentially landslide material. This material down here is likely not. So you can see it's fairly deep. You can also see a water level that goes right through here. That's, again, based on the data that we have of where it's apparent or it appears that the water level is there. Now I moved up closer. Our model basically is saying that we are sliding down a hill on this plane, and as it slides down, it's pushing stuff up here at the toe. And the motel and Dairy Queen see things rising all the time. And that's basically what's being pushed up by all the material that's up here. I'll show you another drawing, but the key areas where it wants to move, today we're seeing movement from here to here. That's where we are today. It doesn't take a whole lot more before it wants to go here and up. And it doesn't take more to come here and up. So what could potentially occur if nothing was done to arrest this movement? I would envision, just as we're seeing today, that the soil here would slump down and become flatter. So it would encroach in the properties below us. Then there's an opportunity, since that has relaxed, it's not supporting the soil up here quite as well anymore. So there's a potential for things to come down there also. All right? Now, future. There's no question that things are moving where we're seeing it today. There is a potential for that to grow if it isn't stopped. I haven't talked about earthquake. Earthquake is an issue that was not addressed years ago. It's something that is being addressed today. It's an item that regulatory agencies like to have evaluated, and a method provided to prevent unacceptable behavior or performance should we have an earthquake. So, let's go back to what we've been seeing before. Remember our red line? The red is the area where I think we have the greatest chance of having things move, simply because we're seeing evidence of movement there today. If I were to take the next step, if this isn't halted where it's at today is that this could grow, and the evidence would be this area here. Okay? Now that's simply based on our model, based on information that is available to us of what the ground surface was like before. What it appears to be is an old landslide within the huge, okay? So we just happen to be involved with the very front end of that today, where it could approach the other area too. Let's talk about options. It's my opinion that something needs to happen very quickly. All right? The quickest thing that could be done without lots of expense would be to put a berm at the toe of the slope. Basically what I'm suggesting is you put dirt down there. 6,000 cubic yards of dirt. What that would be is approximately 15 feet high, about 30 feet wide, and approximately 300 feet long. Okay, that's a lot of soil. The reason why that's such a good option is that could happen relatively quickly. It would obviously entail some covering up of existing pavement. It would entail possibly removing a building that's already condemned. It doesn't have to, but it would sure be nice to go in the area where that condemned motel is. So, here's a figure of what that would look like. Now this profile follows that same red line that I kept showing you, where building L is up here and Dairy Queen is right here. So basically what I'm suggesting is we fill soil, which comes out here somewhere between 25 and 30 feet, and it's 15 feet high, and that's basically what it would take. And that would improve the stability of that slope about 20%. 20% is good for us to then take some time to see what kind of a long-term solution we want to employ. That is not enough for long-term, but that is enough, I think, to be able to take care of the issue today. Ideally, whatever we do will increase the stability by 50%. So there would be the opportunity or option of even placing more soil up here and or using other mechanical methods, which I'll just share with you quickly in a second. So what that means, and the reason I picked those dimensions, is it would entail putting a berm right here, basically filling up that asphalt portion, at least the parking area, and then up into the hillside here. It would entail placing soil here. If this building remains, we would want to add even more material here and more material here to compensate for the loss of real estate right here. All right? Ideally, it would go from here to there, or even more ideally from here to there, because the potential of it moving out to that point there. All right, the other option, long-term. The long-term solution could include all or part of this berm that I'm suggesting you consider right now. It would also include what we call drilled piers, and I'll describe that to you in a second. It would also include some tieback anchors.